This question says that in a semiconductor doped with donor atoms, the number of holes is much higher than the number of electrons. So there's a few important points here. We're going to have doped donor atoms, and then we have the number of holes is much higher than the number of electrons. So with this information in mind, we're going to look at doped semiconductors. We have donor ones, and we also have acceptor ones. With our acceptor, we have an atom inside of here that's +3, and we have minus, 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 because we have to surround it with electrons. Well, we can see that if we have a +3, we have 3 electrons being brought in. This 4th electron is from this bond right here. It goes across from it and adds to here. Now, since that bond leaves, we have a hole right here, and this breaks our covalent bond. And so if we had multiple of these for the acceptors, that means we would have +3 all here, meaning that each of these would be missing an electron. And so we would have a bunch of holes here. However, for the one that we're looking at, this donor one, because we're looking at with the donor atoms, the donor one, we have a +5, meaning we have 5 electrons. So we have 5 minuses. And we have an extra one, right? Because we only have 4 right here, like this. So this electron becomes free and it's out here. Now, if we have a majority of these that are +5, we have a bunch of free electrons. And so that means the number of holes is not much higher than the number of electrons. It should be the other way around, where the number of electrons, if we look at this, is much higher than the number of holes. And so this is going to be false, because this statement right here is untrue.